Hi everyone. Today I will be sharing with you about Azure durable functions for .NET developers. And this is actually my second video or contribution to Azure Back to School this year. And I hope that you will learn something that is useful in your serverless development, specifically for .NET or even in general serverless. So let me just maximize my screen. All right. So before I start, let me just share about myself. So my name is Jonah Andersson. I think you have seen my previous presentation and the earlier um, Azure Back to School content, where I did share about how you can develop with Azure Service Bus and a technical overview about it. So this will be another topic, which is kind of related because I use Azure functions there, but this time it will be durable functions. So before I start, to those that who don't know me, I want to introduce who I am. So I'm Jonah, and I'm currently in Sweden. I work with software development and DevOps engineering, specifically with Azure. And outside job, I'm active as a Microsoft MVP certified trainer. I'm also writing my book and also leading and organizing events at Azure User Group Sweden. And today, what I plan to do is that I want to share with you about the concepts of serverless in Azure, Azure functions, durable functions, the different application patterns that you need to know, example use cases, and some recommended learning resources. And hopefully, we also have time to show you a mini demo or example related to this topic. So, before I start, I want to share with you about the dining philosophers problem, which I actually first encountered when I was studying Java development, specifically in understanding how concurrency works. So, the problem of this problem, which is the dining philosophers problem, there were like five philosophers, and they had like five chopsticks, and when you eat chopsticks, you need two in order to eat one. But to make the long story short, so if each of the philosopher in the table picks the chopsticks from left to right, this means that none of them would be able to eat what they have on the table. So the problems that we see here is, of course, deadlock. That means they can't eat. And of course, if they can't eat, then they will experience starvation. So, my point here on this example scenario is concurrency in terms of programming. So, for example, in this, if we experience deadlock in the traffic, in the crossings, wherever you are in the world, regardless of your traffic rules, if we don't have this traffic rules, then we will be experiencing deadlocks or frustration, and people won't be able to go to work or wherever they want to be from one place, point A to B. So we don't want deadlock, especially in terms of when we're solving problems or we're trying to deliver something in our applications, APIs, or services that are microservices or even distributed type of applications. So I believe that serverless solutions like Azure functions will be able to fix problems like problems in concurrency, racing conditions, and deadlock. And I, as a software developer or programmer who's been, I mean, coding different types of problems and fixing bugs. In my personal experience, debugging concurrency problems can be a challenging one, especially if you are not familiar with it or if you are someone that are new to programming. So I believe that concurrency problems and deadlock can be prevented or minimized by making use of distributed and microservices type of solutions, and also making use of serverless. So now that we talked about serverless, what is really serverless? So serverless is basically an abstraction of servers and infrastructure. This means that you are focusing on breaking your logic into functions without being worried about the infrastructure behind it. So, in this scenario, if we're talking about serverless in Azure, this means that the servers are or infrastructure are being taken care of the cloud provider like Azure, and we as developer who's availing the function as a service or serverless as a service. Is just going to focus on our logic in order to deliver that use case that we want to provide to our clients or business. And the good thing about serverless is that it has the flexibility of paying as you go. Like consumption models, and then you can integrate it with other services within Azure, and even external APIs. It has the option of auto scaling, and then the automation of processes is easier, especially if you're implementing it with workflows that I will be deeping deeper as well soon. And also, of course, developers can focus on their productivity. So no, all developers wants to code, of course, and they want to deliver the task that they need to deliver. So if they have to have if they don't have to worry about the infrastructures and just focus on the logic, then they can be more productive, and they are also happier. So, as you see, this GIF, I like it because it's a good example or conversation that of how serverless is being implemented in many businesses or organization today, and there can be a misunderstanding sometimes, and there can be a good benefit of it as well. So, since I am Swedish and I'm also from Sweden, I want to share with you about the serverless Swedish Fika comparison. Fika is a word that we use here in Sweden if we spend time with our family, friends, or colleagues drinking coffee with something sweet. So I want to share with you about the serverless sweet Swedish Fika comparison in terms of monolithic microservices, containers, and serverless. And monolith, as you can see here, it's like layered cake. You have everything in one place. You have the data layer, you have the logic, business logic, and you also have the application layer, the data, everything in one place. And this can be something that we can relate on the applications that are hosted or deployed in on premises or monolithic architecture. And then we can think of microservices like cupcakes with different flavors and different colors, and they are like a microservice that serves its purpose. For example, in the application world, we know that you're implementing microservice because you're isolating. You have a specific service that handles user management. You have a service that handles um applicate like order management or billing or whatever it might be. But the microservices, the benefits of it is that if something breaks, one of the services breaks, it doesn't affect the other one. So there's that isolation and benefits of that compared to monolithic, as you are aware of, that if something breaks in the database in a monolithic architecture, then that means the entire application breaks as well, and the users won't be able to log into their service. And then the next Fika, something sweet that we have is containers. So they are like biscuits, different flavors of biscuits, all that you need to have a good coffee time with your family and friends are in one container. So just like also what we have today in the modern application development or cloud native, that we are utilizing containers in container technology, so we can have everything, all our application in logical containers, regardless if it's Windows or if it's Linux, or regardless how much applications it is. And the containers has its like benefits in comparison to virtual machines. For containers are lightweight, unlike virtual machines, they can take time to start up, and there's a lot of features it has, for example, like being able to orchestrate it along with your different workloads. And then serverless, which is the topic that we have today, is like sweet candies. They're small. They are small, but they are just good enough to deliver the sweetness that you need. In terms of in terms of Fika, but in terms of software development, it is actually, like as mentioned earlier, it's gonna be focusing on the logic that you need to deliver. It might be you would need an Azure serverless, like a serverless function that will handle sending emails to a user, or something that requires approval workflow, that would require someone to respond on SMS or email. So those small tasks or activities can be handled by serverless, especially stateful or not stateful. So they are like candies. So I hope that my comparison doesn't make you crave for coffee with this cookies and cakes. But anyway, my point in this illustration is about control versus productivity. So as you if you've been in the tech industry or IT development or application development for a while, you know the advantages, the shift that we have, and the evolution that we have been experiencing from monolithic, from the left, to serverless and containers and using microservices. This means that the more we stay into the monolithic architecture, monolithic way of application development, the more, of course, we have control. However, we are less productive because we would need to maintain the servers, we would need to have people taking care of them. And if something breaks, then it will also decrease our productivity. But as we move to the right, to the modern development with serverless or containers, we gain more productivity because we're letting the cloud provider take care of those infrastructure that needs to be maintained, and we're focusing on just delivering to what we need to deliver to the users or the business. So that's the comparison between monolithic to serverless and other modern technologies that we have. And now I want to introduce you to Azure Functions. So most of you that have worked with serverless and Azure are probably familiar with this. If not, so I want to share that Azure Functions is actually one of the serverless compute service available in the platform. And it has the option to pay it as you go, like consumption plan, but there's also the option to use premium plans along with your app services when you're using Azure Functions. And then it's event driven. This means that it gets triggered by something. So it might be a new queue message that came in your Azure Service Bus, or a new blob item that came in into your Azure storage. So it's event driven. This means it needs to be triggered by a certain event. And Azure Functions has the benefits of developer productivity, and it can be well integrated with other services or APIs. So basically, Azure Functions is code that we write or author as developers, and then you would need to decide what events, what how you would want the a logic uh, be triggered, and what kind of data that you want to pass in and out as a result. So if you want to learn more about Azure Functions, I actually created a QR code for you to scan to learn more about it, and I believe this directs you to the documentation of Azure Functions and a video about it. And next is durable functions, which is actually an extension of Azure Functions. And the special thing about durable functions is that it allows us to write stateful workflows in serverless environments. So I know that in the world of Azure platform or Azure, there are actually there are other ways actually to create workflows. For example, Logic apps. Azure Logic app allows us to create workflows that's integrated with Office 365 or email and other Azure services. But the difference between Azure Functions and Azure Logic app is that in Azure Durable Functions, you actually write your or author your stateful workflows by code. And Azure Logic app, you do it in the UI using the Azure portal. So that's the difference of that. But if you're writing something complex that requires coding, then durable functions would be ideal one, especially if you're trying to do this complex stateful workflows in languages like C Sharp, JavaScript, Python, PowerShell, and now they recently supported Java. And the stateful workflows, actually, it's a good thing because you don't have to like keep track you don't need to keep track of the state of your workflows or functions because the durable task framework does it for us already, and there's a GitHub repo about that you can see right now if you want to follow the updates to that framework. So supported languages in durable functions, for example, are this. So there are actually different ways for you to develop durable functions. There's the two options: the in process and isolated. So when depending on what language stock or programming language that you're using, there are different support for that. So there's the support for .NET, other language like JavaScript and TypeScript, and what version that is supported as well. So it's actually documented on Microsoft Docs through that link if you want to deep dive or find out more about the specific language that you prefer to use. And I decided to send you the link because this information or table can be updated depending on how Microsoft up or when Microsoft updates it or do some releases. So it's good to check it out from time to time. So when you're working with durable functions, or before you even try to write, author a workflow in durable functions, it's worth taking note of the different function types. So there are actually about three, four function types. So there's the client functions, there's the orchestrator functions, activity functions, and entity functions. And client functions are actually these are like the normal standard Azure functions that you use to trigger the orchestrator, and usually they are like your this is where you put your trigger, like service bus trigger, I mean the blob trigger, or Cosmos DB trigger, and that has what it does is that it starts the orchestrator, and by calling in the orchestrator function. And the orchestrator function is actually where you write your workflow or code, depending on whatever pattern or complex pattern that you're trying to author in that. And the orchestrator is actually like where you is the blueprint. That's where you put everything that you want to happen in your workflow. This means that in your orchestrator, this is where you write your sub orchestration. This is where you write your this is where you call your activity functions. And activity function, each of them are there actually like a basic unit of tasks that you need to do in your orchestration. This means that there's one activity that maybe after a trigger, a data got passed in after an event or a trigger, then then it will do an activity, or for example sending an email to the administrator, or sending email to your customers or users of your application, or maybe save the data to the database. And then the last one is entity functions, which is another type of function used for durable entities, especially if you're working with that in .NET. So the orchestrator is actually like the Philippine national folk dance. In Since I'm actually also from the Philippines, grew up there. We have this dance called tinikling, which is a traditional folk dance that the people have to be. I mean, the people dancing have to be synchronized in order to dance on the moving bamboo sticks or bamboo bamboo. So if you see in this example, the dancers, her and him, have to be coordinated in order to dance the tinikling. And then the girl and the guy that's holding the bamboos, they need to be coordinated as well along with the dancers. So I want to share that orchestrator is like tinikling, in a way that everything that we write in our workflow needs to be synchronized or organized. So that's tinikling. So you learned something about the Philippine culture. That's good. But anyway, back to the orchestrator. So the orchestrator is our friend in a way that it allows us to write stateful workflows. However, it is actually strict because it needs to be deterministic. It is deterministic in a way because it expects the same results. The same way as, I mean, expects the same result all the time, and the entire workflow that you authored in your orchestrator function will be replayed. So there are certain things that needs to be followed. So this is an example. To the left is an example of uh, I mean, a determined orchestrator, when which you have an orchestrator, and here is an example of like a group or isolated uh, Azure functions, standard ones without an orchestrator. So if you compare left to right, you see that in the left there's more organization and workflow involved, but here on the right side, without an orchestrator, there's a big difference there. So it really depends on what you're trying to solve. But if you require something that has this kind of orchestration, or that needs to be stateful, then this is good to choose the option on the left. So in terms of code constraints, there are actually do's and don'ts when you're authoring your durable functions. So for example, one of the don'ts is like generating random grids or random numbers in your orchestrator functions, like having threads, infinite loop, or putting on your database configuration in the orchestrator. And also GUID So what you can do instead, if you really need to have random numbers, is use the new good method. This is different actually depending on the language that you're using, but that is possible to use instead. And if you really need to have your configuration, you can do it in your activity functions. I think I have that in my a few examples that I will show you. And then if you need, there's already actually, you don't need to create like blocking APIs or threads in the orchestrator, because you actually have that options or feature ready through the durable orchestration context. And infinite loops, definitely a no, the normal one at least. But what you can do is in the context, there's a method called create as new. So if you really need to repeat an activity, then you can use create as new method. And then current date times, as mentioned, since orchestrator needs to be deterministic, this means that you would need to use the datetime method that is through the context, not the normal one that you see, for example, in .NET, because deterministic, as I said, it breaks the rule of the being deterministic. So um, if you want to learn more about the different code constraints, these are just like a few of them. There are actually a long list of the recommended code constraints that you need to be aware of. So feel free to check it out on this link or in Microsoft documentation. So now that we have learned about the different types and the different like purpose or the difference between the orchestrator and how it behaves, that it needs to be deterministic, and it needs to be um, well well written because it will be replayed. It's also important to be aware, at least, of the different patterns that you can use in durable functions that will help you solve complex use cases or scenarios. So the documented ones that we have so far today, as of date of recording, there are about six. So the first one, the first of the pattern is function chaining. And then there's also the fan out, fan in, async HTTP API, the monitor pattern, there's a human interaction pattern, the aggregator pattern. So function chaining pattern works like this. So you have a function, and you're gonna trigger it, gets triggered with any kind of client functions or trigger. And then what it does is actually just like the term itself, it performs the action or a sequence and function in a particular order or like a change. So in this example, function one is actually required. So if you have a parameter or output, that might be a required input for the next function, so on and so forth. So that's the function chaining. So function chaining in action. This is actually animation I created myself. Function chaining in action. So what's happening behind? So, for example, you have uploaded an image to your Azure blob or Azure storage, a blob. So, what it does is that it kickstarts your orchestration or workflow. So, once the orchestrator got started, your first activity gets scheduled, and while activity one is doing its job, the orchestrator sleeps, and then when activity one is done, the orchestrator sleeps again. Activity two does his works, and then orchestrator sleeps again. Activity two is done with his or her work, and then the orchestrator is completed. This is just a mini example. If you have a workflow with only two activities or two tasks to do, so the entire orchestration with this function chaining will be replayed every time you upload blob or an image to your Azure storage or whatever that client or trigger that you have. So it will be replayed, uh, and the good thing about this, like behind the scenes function chaining in action, as an example, is when the orchestrator sleeps, you're actually not paying, or you're not charged for the instance of the activities that are running. So that is good, which allows you to save some money, and have better control, compared to just having normal standard Azure function here, Azure function there. So you have more control, and you have a good overview of the entire workflow, and you know what's going on, and you can always update or manage it by code. So the orchestrator can be sleepyhead like my dog Lawrence, but it's good because we can save some money in terms of the consumption or instances. And of course, you have more control, as I mentioned. So serverless function chaining, in real example, this is one of the examples that I have a template on. So here is a mini example where you have a blob trigger that kickstarts the orchestration when it gets triggered with an image upload or blob upload. And then the orchestration is designed to have the function chaining workflow, which means I have the first function that's once I receive that blob image data, uh, I'm gonna send it to the send a message or create a queue message, and pass in or send it as into an Azure Service Bus queue. And then once that Service Bus queue message has arrived in Service Bus, what it does is that the orchestrator will call the activity called send SMS, or call via Twilio, which actually talks to the Twilio or integrated with the Twilio API, and sends a message, or and also a call to the administrator of this like application or workflow. And it will also send an email using SendGrid API. So this is just an example, a simple example that shows that durable functions can be integrated with other services in Azure, like Azure Service Bus, and other external APIs like Twilio and SendGrid to do other tasks like sending emails, sending SMS, or and making calls for us. So, if you want to try this out, I actually created this mini code or repo as a template. Currently, I believe this is in .NET Core, and I haven't had a chance to upgrade it or do a version with .NET 6 and 7 coming soon. So, but if you want to just try it with and look at the code and try it with .NET Core version that you have, feel free to clone and use that template that you see on this GitHub link. So the expected results that I had when, if you do it yourself as well, is that I will be once I uploaded the image in my Azure storage, I will be getting that queue message in my service bus, and then I will be getting an SMS through Twilio, and then I will be getting a call, and then I will be sending an email. So it comes in sequence, just like function chaining. So the next pattern, second pattern, is also fan out, fan in, which is a very useful pattern to be aware of in terms of making complex workflows that will require you to execute multiple functions or tasks in parallel, and then you have to wait or aggregate the results when it is done. So common scenarios that we can see, for example, for a fan out, fan in pattern, this is in C Sharp, code snippet that I borrowed from the Microsoft Docs. So in here, you will see that in the fan out, fan in pattern, you have a function that actually does the parallel tasks, or what you're trying to do. You're getting a list of work items to do that will run in parallel. And you see here, it has this call activity as things that check on the work batches that needs to be done. And then in that work batch or list of objects are looped, and then in each task in that work batch you're gonna do something. So in here it uses the keyword await task when all. This is the fan in part of it when you use when all. And then when all of the parallel tasks are done, then you're gonna, for example, aggregate the result. For example, in this scenario or snippet, it's trying to get the sum of the results and then return it, or pass it into another function, which is actually called function tree in this case. So that's the fan out, fan in pattern. And then the third pattern that's good to know as well is the async HTTPI pattern, which is actually used for long running operations with external clients. So this is useful if you want to use HTTP endpoint trigger for long running operations. So here is a very simple example that I have where I have a long running HTTP async example where I want to check if my website is available. And in here, I use the iDurable orchestration context. And in the try catch block, I have my URL. And then I use the durable HTTP response and passed in my desired method, HTTP method. In this case, it's get, and then my URL of my website. But this can be an API endpoint that you're trying to talk to that requires to be long running. And here I just have like a simple if else block where I check on the response status code if it's 500 or something else, and then I process or log that information. And if there's something wrong with the HTTP request, then I do the exception handling, and I can do furthermore in the catch block. And then the fourth pattern is the monitor pattern, which is actually used for recurring processes in the workflow, just like, for example, in a periodic job cleanup. So here is an example in Microsoft, from Microsoft Docs, about monitor pattern in C Sharp. So here we have a function name called monitor job status. And here we have variables like your job ID, polling interval, your expiration time, because of course you want to know, you must have like a basis when your job is going to expire. And in below that, we have a while loop that actually checks the current date time through the context and compare it with the expiration time that you set. So here we have a variable that checks or calls an activity called job status, and then it passes in the job ID. So it checks the status of that specific job ID, and then if the job, it has a check. If the job status is completed, it's gonna send an alert to a specific machine ID. Otherwise, it will do that. Otherwise, it will check until the next pooling or monitoring job. So by this, if you see here, next check, the variable net check, it's actually like the orchestrator sleeps until the next check. So you actually passed in your pulling interval here. So the orchestrator will sleep until it's time for next check. And then you can actually create a timer, a durable timer, to make control of that monitoring workflow. And then the next one is actually the next pattern, which is also a good pattern to know, is the human interaction pattern. So as the word itself describes, it requires human interaction. So this is typical if you want to automate a business process that require human interaction for example, approval. So this is like a good use case scenario, like you have something that requires approval from someone. So what you can do is that you request for approval, and side by side, you can have an external event where a human being respond to that approval request, or you can have a durable timer and do the automation process if that external event doesn't have any response in a certain time. So here in this scenario, you have a request approval. It's either a manager or a supervisor approve it. And if that person is on vacation, there's a durable timer that checks on that. So if it's okay, uh, after approval, it processes it. Otherwise, it does the escalation. Maybe another person needs to approve it. Well, the first primary contact is away, for example. So here's a code snippet implementation of approval workflow in C Sharp. So here you also have the iDurable context where you're trying to wait for the request approval. And you have the timeout, durable timeout timer that you set. And what it does is that you have a Boolean here that wait for external events, and it's gonna check in between the external event or response from a person, might be a reply from on an email or SMS, and then it's gonna wait. And when any of those event approval or durable timeout happens, it's gonna do its processing. Otherwise, it's gonna call another activity or task called escalate. So this is an example implementation of an approval workflow. And then the last pattern that's good to know is the aggregator, which is actually used for stateful entities. So here, what it does in simple terms, it's going to aggregate the event data over a period of time. And this data can be coming from different sources, and they can come anytime. And this pattern is actually useful to if you want to capture uh, the event data without like losing their state. For example, this pattern is actually hard to implement if you're just using normal functions, because you would have to keep track of the state or when this thing when the data is coming in and out from different resources at any time. So this is a good pattern to know for stateful entities, and you see how the example here on how it is done in C sharp. This itself has this very powerful pattern. So if you want to check it out, learn more, uh, check out Azure Functions durable and undurable function entities. And I know that, for example, Azure Functions University or another MVP, Mark Duker, has a good example about the implementation of durable entities in .NET. So feel free to check out his channel, Azure Functions University, on YouTube and even on GitHub. All right. So those are the 6 patterns that we learned. However, there are actually you can create as many patterns as you want, and make use of sub orchestrations in durable functions. So in certain scenarios, you might need to author workflows that are more complex than what was, mentioned, the different patterns that were mentioned. So in your orchestration, in a specific orchestration, you can actually create sub orchestrators under it. So in your orchestrator, you can have a sub orchestrator that maybe handles a certain group of tasks, and then another sub orchestrator that handles another set of group of tasks. So this is currently, as far as I know, currently supported in languages like .NET, JavaScript, and Python, and not in other languages yet. So definitely worth checking out if you are trying to solve more complex uh, workflow in your projects. So this is how it looks in C sharp by code. So here is just an example of provisioning devices where you have a list of device ID. And what it does is gonna have a for each loop that goes through all the devices in that list, and it's gonna call a sub orchestrator called device provisioning orchestration and passed in the device ID. And in that orchestrator, our orchestration, it has its group of tasks as well that is being performed per device ID that's being passed in here. So it uses the fan out, fan in pattern in a way that it has a list of devices calling a sub orchestration for each device, and then it's gonna combine the result and aggregate it as well. So yeah, so that's an example of sub orchestration. So if you want to get started developing Azure functions, there are a lot of ways and tools to do that. So there are a lot of free resources in Microsoft Docs. But if you the basic things that you need to know, you can develop through Azure Portal, Azure CLI as well. The tools that are being used like commonly is like VS Code and Visual Studio, and you would need to install Azure Function core tools, especially if you're working locally, because Azure Functions or durable functions allows you to debug locally. So that's the one of my favorite features actually, even before deploying it. And Postman is what I usually use for like web requests. And then there's also a plugin in VS Code called REST Client that allows you to actually call or do requests, HTTP requests from the code and get the results there when you're trying to test locally as well. And then Azure Storage Explorer, if you're working with your storage. So Azure Functions is actually integrated with Azure Storage because that's where you store your instance details and logs for the web jobs. Then it's good to have it locally, and it's free if you want to download that. Otherwise, it's also available on the Azure portal. And as I already mentioned, it supports many set of languages. I've used it in JavaScript and C sharp. I haven't tried it yet in Java and PowerShell, but I know in PowerShell, the Cloud Katana is actually an open source project by Microsoft, which is used for cloud security in Azure in terms with Azure AD. So it uses actually PowerShell to with durable functions to simulate attack and defense in the Azure AD. So if you want to check about that, you can look up Cloud Katana by Roberto Rodriguez. That was also partly involved earlier in that project. So if you're coding durable functions, they're good to know. So you can exactly implement it just like the normal cloud development. You can set it up with Azure DevOps, your pipelines in different ways. You can automate it, infrastructure as code, and make use of application insights, also deployment slots or conscious versioning, as well as using Azure Key Vault or managed identities for protection and security of your serverless functions. And in terms of error handling, there are so many ways to handle it. Of course, aside from the typical try-catch block, what you can do is, in order to prevent function failed exception or whatever error, you can control or do error handling or logging by making use of, like, for example, the automatic retry on failure, call activity with retry async, and then you pass in the parameters it requires. There's also durable timers, and then there's also the app insights, which is part of Azure Monitor. Durable functions monitor is also available that you can check more in details on that GitHub link. And you can read more about durable functions, error handling, and best practices on the link I provided here below. So now it's time for some demo. Let me just go minimize this one for now. And let me just go ahead and show you my demo. Let's see. So here is that one is the previous example that I had. You remember on my previous in my previous presentation, I had like Azure Service Bus, where I have Azure Service Bus queue sender that reads the list of people in the JSON format. So they have like, I have a JSON file here and an object called person. And then what it does is that it's going to read the names and the files of, and make a list of that list of persons in a JSON file. And then it's going to send a batch messages to Azure Service Bus queue. And then it's going to save it as a queue message. And earlier also in that, I uses the normal service bus queue trigger to trigger that function. But this time I'm going to be using durable functions actually to to receive that a message. So what I have here, let me just zoom in. So in my Visual Studio right now, I have a project called Message Sender Service Durable Functions that I created recently just for Azure Back to School session. And what I have here is I have my client functions. This is how I actually do it. I group it based on the type. So I have a client function called service bus queue trigger. And what it does is it gets triggered every time there's a queue message that comes into my service bus queue named Azure Back to Schools queue. And then here I have my connection string and I have my durable client. And what it does here in line 28, it's actually gonna start the orchestration by calling the method start new async, and it's going to call the service bus orchestrator, and I'm passing in my service bus queue item. And in here, my orchestrator, let's see, in my orchestrator function, which was the orchestrator that's being called, where I have a simple workflow in a try catch. So here I'm in line 20, I'm actually getting the input of from the queue. So what I'm trying is I'm getting the queue service bus queue message as a string, and then checking out here in line 22, I'm checking if that queue message is null or not. If it's not null, it's not empty, then what I will do in line 25 is that I will be sending an email. I will call an activity called send email and pass in that string message, which is equivalent to the service bus queue message. And then in my activities folder in this repo or project, I have this activity, which is actually uh, static class of activity called send email. And it it uses activity trigger, and what I have here is that in the try catch block, I am gonna be sending an email, which is an async method uh, locally in this class. And in my async method, I am here in line 36. I am actually passing in my service bus queue message. And in my try catch block, starting from line 41 to 42, I have my API key, my email address, recipient email address. This one is I have it in my environment right now. Currently, it's local because I'm working with this locally, but my plan is to implement Azure Key Vault to this, so I don't need to just do it locally. And then I have my API key. So this means that on line 44, before I could put in my API key, I had to register for the app or to get an API key on SendGrid. And this is the same API key that I used in the previous demo that I had in September the 2nd. And then I'm creating a message, a SendGrid email message from address from me. Subject, this is an email received because there was a service bus queue message that came. And then my content for that message is literally the queue message string that I created from the previous service bus queue sender, which was the console app in the previous session that I had. So I'm gonna add a recipient, which is the recipient that I have here, and then 53, line 53, I'm checking the response, and I'm doing some logging. And what it does is that if my response is successful status code, then I'm gonna log email queued successfully or something went wrong. And here I can also process more or do some more error handling. So that is my example for this one in relation. So it kind of connected with the service bus session that I had and how you can do it with durable functions. So I will be sharing the link to this repo so you can also check this out along with my session. And I hope that it will help you get started working with durable functions with Service Bus or any other Azure services. So now let me just go ahead and continue my. So that was my demo. So let me just continue more. So in terms of deployment, so the demo that I showed you is not actually, I haven't set up the pipelines for that yet, but you can actually set up your pipelines the same way as other applications, set it up with GitHub Actions or with infrastructure as code, or you can publish it in a app container or container registry and fix it the way you want it normally. And in terms of learning resources, I would recommend this list of our learning resources. So follow Azure Functions in Microsoft, Learn, Twitter, and I did mention another MVP in the community that's very active in sharing about Azure Functions. So if you want to contribute or learn more from the content, feel free to visit that one. And there's also a list of Azure Serverless community project that you will see in the serverless library.net from the different people in different languages. And also you learn by teaching. So serverless bit project was one of the projects that I was involved as a serverless mentor. So they have events every year. So if you're interested to be a mentor and learn serverless that way by teaching, feel free to be part of it and check out bit project. And finally, I want to share that as a developer, I love serverless because it helped me solve complex problems, and I can build modern apps, and it makes me productive. So thank you so much. And if you want to contact me, Feel free to scan the QR code to reach out or ask questions related to this topic. And if you wanna grab this Azure Heroes Learner Badger because you learned from my session today, feel free to scan this QR code. And thank you so much, Azure Back to School, for having me. I hope that you enjoyed my session, and feel free to share it on your Twitter, LinkedIn, and do the hashtag Azure Back to School today. Thank you. Have a good day. Bye bye.